In this video, let's take a look at practice quiz for standard 6 on piecewise and inverse. We're going to, in number 1, use the graph below to write the domain and range of the function. And so what we want to think about for domain is how far does this graph go to the left. So I see this piece of my graph is going to go left and it's going to continue to go left. So I would write, that means that's going left forever. So we put negative infinity and use a parentheses because it never equals infinity. And then when we go over to the right, we see that 1 is included. All the points in between 1 and 2 are included. 2 is included. And then all the x values after 2 to the right are included. And so we would put that this graph will also continue to the right forever. So we put positive infinity. And so remember, you want to put the left first and then the right. And then for the range, you want to think of the opposite. You want to think of how low does this graph go? So I see that it goes down to 0 and it'll equal 0 because there's no hole in the graph or anything like that. It's a solid curve. So it's equal to 0. So we need to put a bracket with 0. And then it also goes up forever. And then like no values in there would be missing. So we could say this goes to infinity because that piece of the graph goes up forever. And then if one piece of the graph goes up forever, the whole thing is considered to go up forever. So that's the domain and the range. Let's look at evaluating f of negative 2. So we want to find y where x equals negative 2. So find y where x equals negative 2. So if I go over here on the graph to x equals negative 2 and then go to the function, you want to think, what's the y value right there at x equals negative 2? And it is 4. So that would just be the answer for that part. Number 2 says to write a piecewise function to represent the graph below. So a couple things we can notice is that they have different symbols. So we can either look at this part to eliminate something. We can also just use Desmos to type them in and pick out the right one. So let me bring up Desmos. Let's see. So I have that. And I just want to use Desmos to check and see which one would be the best fit. So for number 1, let's take a look at how to type in a piecewise function again. So we have 2x squared plus 5, and then we need those curly braces to type in the domain, which is x is less than or equal to 0. And then I have negative x squared minus 2, and then I need the curly braces again to put in the domain of x is greater than 0. So I noticed that the second one I put in blue is this one. And it has greater than, but not equal to. So like that would be an open circle. And on my graph in Desmos, I can tell that like that's this one right here. And that is not matching up with what's on my paper. Like these look like they're going the opposite way. So like I don't think it's going to be this one. This one doesn't seem to fit. So then let's compare that to the next option. So I have 2x squared plus 2. Let me adjust what I have in Desmos. And then x is just less than 0, but not equal. And then I have x squared minus 5, or negative x squared minus 5, excuse me. And then I have x is greater than or equal to 0. So now let's see, this would be closed circle. And it still looks like it's down, it'd be like down at negative 5, which is not what's happening on my graph because I don't see a piece of it like right here. So then that doesn't look right either. All right, so let's look at option number 3. So we have 2x squared minus 2, where x is less than or equal to 0 for the domain. And then negative x squared plus 5, where x is greater than 0 for the domain. And let's check and see if that one makes sense. So that's looking better because this red one is the first one. And that would be, let me draw it over here. So like this is the red one on Desmos. And I can tell that like that one makes sense because it's a closed circle. And this one would be closed because it's less than or equal to. So, let me spell that better. So it's a closed circle for that one. And then I can tell this one would be open and looks like what's also in Desmos on my screen over here, and it touches at 5. But notice in Desmos I can drag it over and it's open. And I can also look on my paper and see that that would have to be open because it's greater than 0 but not equal to 0. So then this third option had to be the 1. Okay, so let's look at number 3. We want to use the function below to find the function values. So you can solve this with a graph, or you can just plug them in. First, I'm going to start by plugging them in, and then we can look at the graph and check our answers. So if I want to plug in x equals -2 into this function, I want to see where would that make sense. And so I just usually like to write it closer to my function and think through, is -2 less than or equal to -2? And it is. So we got to plug it into this piece of the function. So that would be 2 times -2 plus 8, which is -4 plus 8, which just gives us 4. So that's it for that part. And then we want to plug in, and this is supposed to say f of 6. So don't mind the G right there. So let's plug in x equals 6, where it would belong. So is 6 less than or equal to -2? No. Is 6 between -2 and 3? No. But 6 is greater than 3. So it's going to go in this third piece of our piecewise function. So we're going to do the square root of 6 plus 3, which gives us the square root of 9, which is just going to be 3. And then again for part C, these are supposed to be F. Let me get another color. So we need to find f of -2, which we already found for part A, which is 4, minus 4 times f of 6, which we already found for part B, which is 3. So we just need to put those things together and multiply the 4 times the 3. So then we get 4 minus 12, which would be -8. Now, let's just check those first two by graphing. And then you would still need to put together part C without your calculator. So 2x plus 8, and then we need to put in the domain is x is less than or equal to -2. Then the middle piece of the function says x squared minus 3, and the domain is where we have -2 is less than x is less than or equal to 3. And then we have the square root of x plus 3, and then I need to scoot over outside the radical and put the domain is x is greater than 3. Okay, so I've got it all typed in. Now let's just check our numbers here. So where x equals -2, I want to check and make sure I get 4. So I'm going to type that in. X equals -2. And then where they touch, notice the y value right there is the 4. So that would make sense for that part. And then for 6, f of 6 means to find x equals 6. And then where they touch, I get 3. And so that's a great way to check your work, or you could even find the values that way. But then part C, you would still need to put together on your own. So number 4 wants us to graph the piecewise function. So let me pull Desmos back up. And we're just going to type it in and then transfer it to our paper. So I'm going to put in 5, which you can also put in y equals 5, since 5 is just all by itself. And then let's put in the domain in the curly braces, which is x is less than or equal to 2. So let's see, let me hit home, and I can drag it over and see that the endpoint is at 2, 5, and it is closed. It's closed because it has an equal to bar underneath it. So let's go to 2, 5. So 2, 1, 2, 3, 4, 5. Put a closed dot. And then it's just at 5. So you just draw a horizontal line going off to the left. And then the second part is 2x minus 4. And then I'm going to put the domain is x is greater than 2. So I see that my endpoint this time, I can look on my paper and see that it should be open because it's not equal to 2. So you got to be careful with Desmos because it might show you that x-intercept is what it's doing, but really the endpoint is undefined. So at 2, 0, I want to put a dot and leave it open. Then I just need another good point to plot. So I see 4, 4 is a good point, or it looks like 3, 2 is a good point as well. So I'm going to go to 3, 2, just to give me another point and draw the line going off to the right. This one is just graphing, so all you have to do is what I did. Type it in Desmos and then transfer it accurately to your paper, but make sure that you show when they're open and when they're closed. Like make it nice and obvious on your paper so I'll know which one it is. All right, the last one is to find the inverse of this function. So let's switch x and y. That's our first step. Let's write that down. Switch x and y. So that means they trade places. So x is equal to 3y squared plus 4. And then the second step is just to solve for y. Okay, so let's subtract 4 from both sides because we're trying to get y by itself. So we get x minus 4 is equal to 3y squared. Then we got to divide both sides by 3 to get rid of the 3. So x minus 4 divided by 3 is equal to y squared. But then we got to get rid of the square. So to get rid of the square, we got to square root both sides. But remember, when you take an even root, when you're solving and you take an even root, you've got to put plus or minus out front. And then put that little inverse symbol behind it. And you can leave it as y, or you can go back to the original beginning of the problem and put f to the -1 of x, which is technically what we have now. We just used y while we were working it out to make it a little easier. So that is it for number 5. And that is it for our practice quiz number 6.